All right, folks, let's get started. So we got a question already, and I do just want to remind folks that the purpose of study halls is to bring your questions, so do feel free to post your questions. I will get to them as I can. We've got a few already, so let's look through these. So this first one is, can I go in depth on dictionaries? Having trouble. I'm sorry. I'm having the most trouble understanding enumerate with nested lists inside of dictionaries. I'm trying to wrap my head around how everything is indexed and how to add or subtract items to create new lists. So sounds like you want to work with dictionaries whose keys refer to lists of lists. Cool. Let's see. All right. Let me copy this in so I'm going to copy in this question so I can kind of reference it. And to the person asking this question, can you confirm if I'm understanding correctly that you're wanting to work with like dictionaries that contain lists of lists? That sounds like, I mean, that's what I'm gleaning from this. So can I go into depth in dictionaries? Wanting to understand enumerate. Oh, come on. Understand enumerate with nested lists inside dictionaries. Okay. I'm trying to wrap my head around everything, how everything is indexed and how to add or subtract items to create a new list. Okay. So I want to be a little, there's information in this particular question that I don't want to really give away too much. And I also want to think of a good problem, a good example that we can go through. And if you have an example, if this is from a problem in Learn or from somewhere else, if you have something specific, feel free to post that to the person asking about dictionaries here. Otherwise, I'm going to think of an example for us to go through. So I'm trying to think, maybe we could do something with text processing. We could have I could think of something with like doing like something with a word frequency dictionary, or maybe a dictionary that has keys that represent the frequency of a word in a body of text. And the values would be a list of all the words that have that occur with that frequency in the text. Perhaps that could be something we could go through. But let's just look at the structure. So I think one thing that occurs to me is when you're working with a dictionary, it's useful to write down what I'll often call a schema, the root there being the same as schematic, right? Like, so it's useful to kind of write down like a plan or a blueprint for how the dictionary is going to be structured. So what I was just describing is a dictionary where the keys are frequency, and I'll often do something like angle brackets to denote that I mean like whatever the word in the angle brackets means, right? So frequency as keys, and then the values will be a list of words with frequency equal to the key. So we'll have a list of words with frequencies equal to the key, and those will be obviously of string, type string, and the frequency will be of type int, right? So this, I mean, honestly, this is kind of a scratch work notation. You know, I'm trying to make something that's going to make sense to me. This is not really a formal notation standard, but it's objective in the sense that I'm making a description of what I want each thing to be, and I'm noting the type that I want it to be. So I'm going to say the key is going to be the frequency represented as an integer, and the value is going to be a list containing words with the frequency equal to the frequency. Excuse me. The values equal to a list of words whose frequency is equal to the key. And those words are obviously going to be strings. So this is kind of like a list of lists. We could index into those strings like they were lists, for example. So we have a collection of collections, i.e. a list of lists. We could have a list of lists or a list of strings, something like that. Cool. So let's do something like this. So let me grab some text here. Let me grab this here. So I just have this little sample text. This specific example, I went through and removed all the, oops, I was going to say all the special characters, but then I saw this. What is this? Just some extra characters floating around there. That is, got a little bit of a corrupt file there. Must have meant to have been apostrophe. Oops. Okay. Let's do that. So this is going to be my sample text, and I want to write a function that takes in this sample text and returns a dictionary with this schema. So the question is, there's another problem that I do that's kind of similar to this, where I'll have the words as keys and the values as the frequency, but now I want the frequencies as keys and the values to be a list of the words. Well, okay. So what should I call the function? So let's print something is going to take in this variable, which is, I'm going to call my text. Just rename this my text. So what should we call this? So the key is, so what's being described here? Words of a given frequency dictionary. That's what it is. So the values are words of a given frequency. Let's call it frequency of words. We'll call it freak of words there. Okay. So let's define this function. So now I hope it's clear. I'm going to call my argument text here and put a pass. So I hope it's clear now why I did this. Right. I have an idea of the dictionary that I want to end up with. So I don't have to make up the structure while I'm solving the problem, right? It's, I'm going to say, important to have an idea of, especially if you're working with a function that returns a dictionary or even a list. If the list has any complexity, like if it's a list of words, for example, or a list of lists of numbers, you might want to like write that down and kind of build out a structure, maybe even give an example, right? So, and we could even, this is a general structure, but we could have a specific example. I'm not going to go through here and like manually do this for this whole thing, but we could, let's say, for an input of like I'll just do some silly text here, like an input of hello world. Let's do something, hello there world, hello world. Okay, cool. So the output for this second function should be a dictionary with key of 1 and all the words that have a frequency of 1, which is going to be there and, oh, that's it. Oops. And then a key of 2 and a value of list, hello, and world. W-O-R-L-D. Okay. I'm just going to comment this out. There we go. So I know that for this particular example, I'm looking for this output, right? So, I mean, you can see how much time I'm trying to spend like getting a clear idea of where I'm headed, and this is going to help me that I don't have to do this like after I think I have a solve. It's important to do this before, that way you know when your problem is solved. Okay, so we have our text. So the first thing is I need an instance of every word in a list, so we can use .split to do that. If I say text.split, I can iterate through this. I can say for word in text.split. I'm going to pass for now. Well, I can print out word, and that'll show me that I have an instance of every word. We should see whose woods these are, I think I know, etc., right? All the way down there. Okay. So that's one thing we can get out of the way, and we'll obviously fill this out more. I also know I need a dictionary. I don't know what the keys are in this dictionary ahead of time, so I'm going to let those categories emerge as we go. So I know that I'm going to call this word list equals text dot split And we'll do word list here. Okay. So I know I can get the frequency of any word by doing, let's do word and word dot count. Oops, I did this wrong. I'll print out the word and then I'll print out the word list. That's what I meant to do. Dot count word, and this will give me the number of occurrences of word in the word list. Okay, so let's just look at this second smaller example. For now, we'll just comment out the big example. And this will show us hello is 2, there is 1, world, hello, and world are 2. Okay, cool. So now I basically have a I basically have all the elements, you know, like I have an access to each word, and I remember in my structure here I want to have the words inside my list, so I need to be able to access the words. Those are strings, so that's good. I don't have the list yet, but we'll get to that. And I have the frequency, which is an integer, which is really the count. I'm calling it frequency, but it's a synonym for count in this case. Okay. So now the goal should be to make the key exist if it doesn't exist as a key in the dictionary already. So I'm going to say if word list dot count, the key needs to be the frequency, right? So this is the frequency of each word. So we'll say if word list dot count word in d dot keys. You technically don't need to say dot keys here, but I like to be explicit, you know, just make it clear that I intend to check keys, but you can leave the dot keys off in this case, but I think it makes it just, I don't know, clearer. So I use dot keys. It's just a stylistic preference, though. You can do what you like. So if that is a key in the dictionary, actually I'm going to say if it's not a key in the dictionary. So if word list.count word not in D, then I'm going to say, let's do this. Since I'm taking this frequency in multiple places, frex, we'll just save this frequency in a variable. That way we only have to run this method call once. And I think that just makes sense. So freq equals word list.count word. So if the frequency is not a key in the dictionary, then let's make it a key in the dictionary. So we'll say d sub frequency equals an empty list. So we'll make it an empty list. And then now that we know the key is guaranteed to be in the dictionary, either it was in the dictionary already or it wasn't and we just added it in. Now we can say d sub frequency. So here, this is kind of where the magic happens a little bit. Let's print this out. So think about what this is going to be. If I print that out, what's that going to be? I'll give you all a second to think about it. Put it in Slack if you want to, in the thread for this. Kind of chew on it a second. You don't have to put it in Slack, but you know, if you want to. So think about this. When you access a key in a dictionary, it gives you back the value associated with that key. And the value we just said is an empty list. So if I print this off, I'm going to get empty lists. if my code ever runs. There we go. So there's a bunch of empty lists. So what I can do is I can treat this like I would any other list. Oh, I just realized I want to return D. I know that I want to return D, so I can just write that in as soon as I remember. Usually I'll do that like first thing. I'll write in my return variable and then I'll return it like right away before I even write any of this code, but I forgot this time. So as soon as you remember, just go ahead and return the thing that you know you're going to return. There's no sense in like working up to it and then doing it last. I see a lot of people that like they don't want to write in the return until they're finished with the problem, and I'm like, to me, I'm like, well, you know, don't you want to see what you're returning? I've even had people where I'm like, hey, go ahead and return that thing and run your code, and they'll write in the return and then delete it, and then keep working. I'm not exactly sure like what the thinking is behind that, but I've noticed a few people do that. So if you find yourself like not wanting to write in the return, yeah, there's essentially, I'm just going to put it bluntly, there's no good reason to not have a return value in before your problem is solved, right? So the problem is not solved yet, but we can just put in the return as soon as we think of it because it's nice to have it there and we can monitor what's going on, right? So I can run this and kind of get an idea of the structure of D already. So I have two key value pairs. Um, I have 2 and 1 as keys, and they both have empty lists. Great. So I can refer to each of those lists as D sub 2 or D sub 1. Frequency, this variable frequency, is either, it's one of these integers, it's either 2 or 1. And we know that because that's how D gets its key assigned, is from frequency. So I can say D sub frequency is that list. The name of the list at each of these keys, the name of these values, is D sub frequency, right? D sub 1 or 2. So I can treat this list, it looks like a dictionary, or it looks like maybe something else. I can treat that list just like any other list, and I can append to it. So once and I'll do this right here. So notice the indentation level, right? I'm inside the for loop, but I'm outside of the if. And what this means is that since this if checks if the frequency is not in the dictionary and adds it in if it is, after that, make sure that that key is in the dictionary, then on this line, I can guarantee that D sub frequency exists and is an empty list. Or maybe not an empty list, but a list. So this will be valid code after that if statement. So if I do it before, or if I do it without that if, this would be invalid code because first of all, I would get a key error. And second, I wouldn't be able to guarantee that it was a list that I could append to, but in this case I can. So we'll say dsubfreak.append word. We'll just append the word and return D. I think this will do it. I might have an extra step here, but we'll see. The great thing is I don't really need to think about is that going to do it, or is there an extra step? Because I can just look at the output and see if it matches my expected output here, right? So remember, this is what's nice about doing this beforehand. I already thought about what I need this to produce, so I don't need to like rethink through that every time since I thought about it and wrote it down. So this is really close, but notice I do have duplicates in the list. I have hello world and hello world. So I could call it here, but duplicates don't seem that useful. So what I'm going to do is say if word not in D sub freak, then we'll append it. And you know what I want to do? I think I want to do dot lower here. I'm kind of thinking out of scope here. I'm thinking about what if I have capital letters or whatever, but you know what? That doesn't really matter. That's kind of a problem for a different function. So if the word is not a member of the list that can be found at D subfrequency, then, so if it's not a member of that list, then I'll append it to that list. Otherwise, I won't append it. So let's look at this. So the order is different, but that doesn't really matter, at least not with dictionaries. The order is trivia, so you know, whether it's this way or the other way, it's still the same contents. So we have two and hello and world, because hello and world appear twice, and then we have one and there, right? So I know it seemed like this question was targeted at something fairly specific. And again, if you have a specific example of this, I wouldn't mind revisiting this. I do see somebody else has a question, and I want to get to that. But I don't mind coming back to this if you could give a specific example of like a problem that you were working through. I'd be happy to like come back and revisit this because this is a pretty cool set of challenges. And I know it's not exactly like what you were what you were like going through or working with. You were talking about like using enumerate. But yeah, I hope that this is going to give you some like general rules for working with complex dictionaries. That's what I'm trying to make this about in answer of your question. So let me know if that was helpful or if you have other specific points of interest with this kind of thing. Please, you know, let me know. All right. Cool, and we've got somebody else asking a question. Can I go over the enumerate function challenge 3? Yes, if you send me a link, I will go over that. It's much quicker if you give me a link for me to find the problem than it is for me to like search through and find it. We cover material, like we'll cover the same material in like sort of multiple phases. So sometimes like I'll find something that seems to match but isn't exactly the same. There is a problem statement given here. Alt series, yes. I know this one well. Every couple weeks, I think I help somebody with this problem, which is fine. I think it's kind of a fun one. Cool. If you can send me a link, anyways, I know the problem statement is written below, but it's helpful to have a link anyway so I can go submit it and then like look at the examples there and such. I would appreciate that. Cool. So write a function called alt series. There is also, I remember this this function. There is some copy missing from this description that is important in solving this as well. Thank you. Appreciate that. Come on Slack, copy that link. There we go. Excuse me. Okay. Come on. There we go. All right, number 3. So this one's a little tricky. This note is important to this, which is kind of they kind of sneak in this note down here at the bottom, which will kind of give you it gives you an important part of this, solving this problem. So I'm going to include this. Oh, I'm actually going to include the examples too. So first thing, again, I'm going to try to write out some tests. And we'll just steal the examples because these are essentially tests. Oops. Oh my gosh. Okay, let's try this again. There we go. So these are now simple tests that we can use. There we go. So let's look at this. Write a function called alt series. This function should have one parameter, which will be a list of numbers supplied. So I'm just going to call this num list. So if you're in premium prep, or I think I even talked about this. Was it last study hall on Monday? Where I was talking about? Oh no, it was with a student. So if you weren't in premium prep, I guess you didn't maybe hear me say this, but when you're going through a problem statement for a function description that you're going to write, when you're writing a docstring or notes for a function that you're going to write, or when you're trying to understand a function that's already written and you want to understand how to use it, what you're looking for, and there are multiple ways of looking at this. There are different acronyms that are various degrees of precise, but one simple one that I like is to look for the inputs, the process, and the output, IPO, which I think is a fairly easy acronym to remember. So input, process, output. Most importantly is the input and the output. Often you can discern the process if you know the input and the output. Sometimes the process needs a little more description. Sometimes it's not obvious given those two things. So as I read through this, think about that. Think about when you see part of this text telling you what the input should be and what it should return. The inputs are its arguments or parameters, and the output is the return value, right? And then the process is how it achieves that, how it achieves that return from the inputs. Cool. So write a function called alt series. This function should have one parameter. So there's my input, which will be a list of numbers. So that describes my input. The function should, so it sounds like a process now, in a variable called alt sum, it should sum together all the numbers. Okay, so I'm going to bullet this. In a variable called alt sum together all the numbers from numList, well, that's what I called it, where the values with even indices are added and the values with odd indices are subtracted. So I'll say sum together all the numbers from numList with the values where values with even indices are added. Okay, and I'm going to simplify this further. Values with even indices are added. Values with odd indices are subtracted. Good. In a variable called powSum, sum together the result of raising each value to the power of its index. And then this is just the inverse of that. In a variable called idxSum, sum together the result of raising each index to the power of the value at that index. Pretty straightforward. The function should return these three variables in the order altsum, powsum, and idxSum. Well, since I know what it needs to return, right? So real quick reflection here. It tells me what the input should be. It should have one parameter, which is a list of numbers. This describes a process, and then the function should return these in this order. Okay, so that describes what the output should look like, the return. So I'm just going to return this, and if you want to return multiple things, you can just separate them with commas like this. It will return as a tuple though, just so you know, which is fine. It's actually a really good behavior. So if you don't know what a tuple is, think about it like a list that doesn't have any mutable methods. So it's a list whose size you can guarantee, basically. If you need it to be a list at some other point, you can cast it to a list or deconstruct it to whatever you want with it. Okay, now I'm going to make these exist. Since I'm returning them, I better have things to return. So I'm going to say 0, 0, 0. We'll just do this. We'll declare them on one line. So since I know all of these are going to be numbers, and I can tell that because these are all integers in the output. So since I know that, I'm just going to set these three variables equal to 0 every time. And if that's not correct for one of these, I can come back and change it up here later. But for now, I'll just make that assumption, and this will actually just work fine here. Okay, so let's actually do our process. So what is our process? The function should, in a variable called altsum, sum together all the numbers in numList where even index values are added and odd index values are subtracted. Okay, so I heard sum together numbers in numList. So I need to do something with every number in the numList. That sounds like a for loop to me. So for num in numList, if I print num, we'll see, let's just do one test at a time. 2, 4, 6, 8. And we should see 2, 4, 6, 8, right? Let's just confirm that that's what we're going to get, and that's what we get. We can also see our return value here, which is just these 3 zeros. Now, obviously, that's not the answer that we want, but that's fine. We are returning something that is of the same structure as the answer that we want. So that's at least a step in the right direction. So I'm going to just treat this sort of like, well, I mean, like a bulleted list. I'm just going to go through. I'm going to get alt sum working, then I'm going to get pow sum, and then I'm going to get idx sum. So we'll just go down the list and get each one of these working one at a time. Cool. Okay, so I have access to the value, each element in the list, but I also need access to the index. So I'll say index num, and anytime I have a problem where I need access to the index, I need access to the value and the index in the list, I can write a for loop that's enumerating the collection. So we'll for num in enumerate, for idx and num in enumerate numList. Now let's just verify that that's what we're going to get. We're going to get the index and the num. So the numbers will be the same as before, and the index will be 0, 1, 2, 3. Good. All right. So alt sum. So we'll say if idx is even, we want to add the num to alt sum, else we want to subtract it. So we'll say if idx is even. So in order to determine if idx is even, I can divide idx by 2 and see if the remainder is 0. So if I say if idx over 2 has a remainder of 0, and the way I get the remainder is to use the modulo operator. So I can say if idx mod 2 equals 0, that gives me the remainder. If it has a remainder of 0, then it's even. I'll say alt sum plus equals num. And then in all other cases, i.e. else, we'll say alt sum minus equals num, or minus gets num. Okay, so let's just see if we get alt sum working. So notice we get -4 and we get 4, right? So it appears that I've written the correct code, but this is what I was talking about this note. This note has there's two little notes here. First one says, recall that in order to return multiple values from your function, you can simply separate them with commas. So that's what's happening here. So we got that one, we don't need that. And the other note is that the summation index should start at 1. Now, this is not entirely clear, but it's saying that we should treat the first element, we should call the first element in the list, we should refer to it as index 1 rather than index 0. So enumerate lets you adjust the index number. It doesn't change the elements that it's going to iterate through. It's still going to iterate through all the same elements. It's not going to shorten the list or anything. It's just going to automatically adjust the value of index. So I can tell it, I can give it an integer to start at. So I'll say, I'll tell it that I want the index to start at 1. So if I do this now, run, please. There we go. So now it says 4. So that'll give me the correct answer. And then the other two, let's just do this. Will be plus equals num to the idx. That should be that. Okay. Oops, excuse me. These need to be in the for loop. A mistake. What was that? Huh, 4096. That's, oh, 4096. I didn't expect to see that number. That's a power of 2. Well, that's just downright uncanny. That's very interesting. Okay, never mind. Not important. Okay, cool. So if we indent this into the for loop, then we'll get the correct answer. So let's do that. Sorry for the distraction there. I'll have to look at why that is. Cool. So we expect our return to be 4, 4330, 66282, and what we get is 4, 4330, and 66282. So that looks like it matches. Let's just try it with our other test, and we'll see with that. For this one, we expect 0, 4, and 10, and we get 0, 4, and 10. Awesome. So sort of a trick with this one is this summation index starting at 1. I think the way that this question is written, that's sort of, I don't think this was intended to like be snuck in there in the way that it was, but it totally is. So I think that'll really get you if you're not careful. So cool. Let me know if that is helpful, or if you have any follow-up questions. For now, I'm going to move on to the next question. We've got a few more questions by the same asker, which is great. I really do appreciate people bringing in questions and interacting. Yeah. You're welcome. Good. I'm glad it was helpful. Okay, so now let's go to the next one. So that's the alt sum one. The next one, write a function called tuple creating tuple, and we've got a link for that as well. Actually, I'm just going to we'll do this. Thank you for getting me the link. Oh, you know, I didn't even do the thing I said I was going to do with the link. That's on me. So I said I would submit it. You can see I already have code submitted for this one, but let's just submit it anyways, just to make sure that Learn actually thinks my solution is valid. I think this will work, but it's always want to test your work, right? Like, why does this look more compressed? What I did here, if you have an if or an else, I think you can even do this with a for loop. If there's only one line in it, you can just flatten it down to one line like this, and it'll work fine. So we're going to do that. Okay, that works too. Good. So this is, what is it? Tuple creating tuple. Number 3. Try to keep my solution off screen there. I have a solution for this one of 2 evidently, so. Okay. So write a function called tuple creating tuple. You can do that. Done. Nice. Problem not complete yet. Okay. This function takes 3 arguments called nameTup, ageTup, and jobTup. Let's just do those. So remember, we're looking for input, process, output. There's our input. And I'm just going to do this. And for this, I'll say my nameTup, jobTup, da-da-da, equals, we'll just do some tuples. Takes in those tuples. The 3 tuples are parallel since they contain the same number of items, okay? I'm just going to bullet this because that's what works for me. And each item okay, right, the 3 tuples are parallel since, okay, we'll do this. They contain the same number of items, and each item at a given index corresponds to the other items in the index. Index 0 across all 3 tuples holds the name, age, and job of the first person. Okay, cool. So that's just an example. So I'll say e.g. That's an example of that. Index 1 holds the name, age, and job of the first person. This is just another example. Second person, etc. Okay. The function should return a single tuple where all of the values at each given index are a tuple of the data for the same person. Okay, so this is a good example of a good time to make a schema for the output, right? So let's make a schema. So the output should be something like let's say name, age, and job. So let's say John is 42 years old and works as a I don't know, carpenter. And then actually I'll do this. I'm going to do this on multiple lines. so that it's nice and clear what I'm doing. And then we can say um, Joanne is 23, and they're a acrobat. I don't know. And then we'll say Joe is 55, and they're a accountant. Cool. Okay. So that's gives me an idea of something that I'm trying to end up with. Now this is, I said I'd make a schema, which I generally think of as a generic example. This is a specific example because it has specific names, ages, and job titles. But this still gives me a sense of what I'm trying to end up with. And while I'm here, I can actually just start copying these. We'll do these names here. And then we'll do ages. And then we'll do jobs. Okay. Cool. So I've got to turn this data into this data, and I've got to pass this into here. Whew, okay. So I have my test written, right? Take note, again, take note, like, look at all the work that I've done, and I haven't even started on the solution yet, right? Because this is going to make the solution so much easier. I have a clear expectation of what I need to end up with given this specific data. I have a call that is invoking the function with that specific data. If I run it right now, it's not going to do what I want it to do, but that's the point. It's going to tell me when it's doing what I want it to do. So I think what I want to do is, what do we want to do? I'm just going to call this tup equals a tuple, and then we'll say return tup. And you know what? I'm going to make it a list, and then I'm going to return it as a tup. I'll just call it list because it's a list. Okay, so I'm going to make it a list because I'm going to grow it in size. I don't know if I have like 3 people to make tuples for, or 1,000, or 1, so I don't know what the size of this list needs to be, but I do know the size of each element in the list, which is 3, right? It's going to have name, age, and job for each one. So this is great. We can, this is nice and simple. We can say for name, age, and job in zip those tuples, and then our job is just kind of easy from here. Oh, wait. Oh yeah, I think there's a shortcut way. So I can say list dot append, and then we'll make a tuple name. Actually, let's just be super lazy about this. Copy, paste. I think that's gonna do it, but there's only one way to find out. John 42 Carpenter, John 42 Carpenter, Joanne 23 Acrobat. That's not how you spell acrobat, I think. Whatever. Joe 55 Accountant, Joe 55 Accountant. Good. That's what we wanted. So that problem's solved. It did just occur to me, I believe, if I zip these and I cast this as a tuple, I think it's just going to work. So I don't even think I need any of this. We got to check first, but yeah, okay. So I can just return a tuple of the zipped items. And that's just done. That's just nice and done. So this is making use of, I mean, just built-in features in Python. This is using literally the same things, but this is taking a more traditional like procedural approach to this. If I wanted to take, and I want to show, let's look at a different procedural solution for this. So let's say real quick. Okay, so here's one solution. Here's another solution. And then let's do a sort of a more raw procedural solution. And I want to show this solution because like learning accumulator pattern stuff may not, like solving a problem with a like a straightforward accumulator pattern may not always be the most efficient way of doing things, but it's such a simple process, and it just works for so many things. So I've recently ranted about this, so for those of you who have heard that rant, I will spare you again, but hopefully it'll become clear why the accumulator pattern is so awesome. So we'll still do this. I'm just going to say for I in range len, and I'm just going to get the len of one of these. We're going to assume some user responsibility in that we're going to assume that indeed all of these are going to be of the same length. So we can just pick one arbitrarily, name tup, age tup, or job tup, and I'll just do name tup because, I don't know, it's arbitrary and I get to do that. And then I can say name equals name tup sub I, and do this for the other two. Age, let's do this. What? Okay. Job tup. So that'll work. So I'm just like reassigning these like this. I'm going through a range, getting all the indices in the length of this, and then assigning to the same names. Or I could skip the variable declaration and just put these in directly. And that would also work. So that would also be another working solution for this, or it should be. Cool, that looks good. So let's go ahead and submit these three. So real quick here, for I in range, this is like the most, for I in range len or for I in range something, whatever, This is a really just generic, flat, simple for loop. And then we're doing a list append and using I to glean the elements from each collection that we want, right? So this is really simple tools. If you learn how to use the simple tools, you can kind of just do whatever you want until you learn the sort of more sleek and advanced ways of doing things. So if you're new, shooting for this way of doing things is totally fine. You don't have to get to this like one line business. But yeah, let's actually submit these and let's see what I did here. I said tup list. Let me cross this out, X that out. So I did the initial zip way that I had before. I'm going to comment that out just so I can keep it around. And then we'll test each of these. So the pure procedural way, I'll label them. I'm just going to call it procedural. Vanilla procedural. Okay, the vanilla procedural way works. Let's call this advanced procedural. And then I don't know what to call it. This is still procedural technically, but let's just call this fancy pants procedural. Oh, I didn't actually uncomment it. Yeah, there we go. Cool. So it looks like they all work. I'm going to keep the fancy pants procedural up top. Do this one right here. Probably going to forget I put that there and then come back and look at this question and laugh at it. It's a little Easter egg for myself. Okay, cool. Looks like we've got also another problem. So that was that one. And then this is write a function called replace doubles. Let's see. Oh, we have somebody asking about the zip function. Did this help you understand zip? Well, you know what? Probably it didn't. I didn't really talk about zip. I think it's worth talking about. Let me go to this other link while I have it copied here. That's a good point. I should actually kind of talk about it a little more here. Come on. Chrome, for real. Oh my gosh. And this is, let's see. Replace doubles. Okay, that's this one. We'll come back to that in a second. So, in terms of talking more about zip. So what zip does, one thing you can think about it doing in a practical sense, you can think about it like you have a problem where you have to iterate through multiple collections, like a range and a list or multiple tuples. Zip just makes that easy. So let's look at this solution. This is kind of the one, sort of the one you see it in a lot, where you have three collections. In this case, they could be lists or tuples or strings or whatever of the same length, right? If they're not of the same length, zip is going to zip as many objects as it can, which means, you know, if you have one you have two collections that have 10 items, and then one of them has 3 items, it's only going to be able to zip 3 items across all of that. So, yeah. Okay. So for name, age, and job in zip these items. So the first thing in the for loop is going to be the elements from the first thing in zip. The second thing in the for loop will be the elements from the second thing in zip, etc. Third thing, so job is going to be from jobs tub. So essentially what it does is you pass it multiple collections, multiple lists or multiple tuples, and they don't all have to be the same type. You could have tuples and lists, or tuples and strings, or lists and strings, or whatever. So what it does is it takes those and it gives back elements at the same index at the same time. And you can essentially think about it as returning a list. What it really returns is a generator. So if let's actually just look at this other solution, a fancy pants solution. So if I don't cast this as a tuple, it's going to give me kind of a weird output. It should give me, I think it says a zip generator object. Yes, it gives me a zip object, and it gives me the memory location, or a reference, somehow a reference to the location. 0x 7f8. This is in hexadecimal, right? So this isn't really that useful. So in order to like see it as a list or a tuple or whatever, we have to cast whatever zip returns as whatever we want to use it as. If we're iterating through it, though, a for loop knows how to iterate through a zip object. We don't need to cast it as a list or a tuple in order to iterate through it. But if we want it to be a list or a tuple, we have to explicitly cast it as that. So if I want a list, I can cast it as a list. And if I zip name tup, age tup, and job tup, and I cast it as a list, I get this. Or a tuple, I mean, I get the same structure. It's just instead of square brackets, it's parentheses. It's just a tuple instead. But the inner structure is exactly the same. So either way, hopefully that helps understand zip. Thanks for bringing that up, because I didn't really, I kind of just used it. And I was like, yeah, here's something. This will just solve the problem. So sometimes I forget. I try to catch that, but sometimes I do forget. Okay. Replace doubles. Awesome, cool. Glad that was helpful. And we'll do this, replace doubles. Okay. Is that, okay, I think this is the same. Nope. We'll try to avoid seeing the solution here. So write a function called replace doubles. What am I doing? All right, print. Do I have examples here? No, no examples given. That's all right. Replace doubles. Def replace doubles. Okay. Write a function called replace doubles. It takes a sentence as an argument. So I'm going to call it text because that's what I do. And this we'll call my text. Let's see. Takes a sentence as an argument, then checks for any double letters. For example, AA or TT, and replaces the letters with a single instance of that letter. AA equals A or TT equals T. For example, okay. So if my text, I should do something silly like, hey, the function should be case sensitive. Okay, so I need to test for case. So be sure to preserve the case of the letters. So AA should not be considered a double character. Okay. Okay. Should not be considered a double character. The space character may also be doubled and should be replaced by a single space. Okay. Hey there, period. There's a double space. Okay. How are... Whew. Okay. So this should give me... So this should give me on the output, hey there, E-R-E, delete that double space. I'll have this double H here, that should stay, and then A-A-Y-Y-O-U. Okay. It's still kind of a silly sentence, but that's good. There's some people who it's bothering that I didn't put a question mark there. I know it. I know you're out there. It's okay. I got you. When I can. Like I said, dyslexic, so give me, yeah, just be patient. Cool. Okay. So this function takes a sentence as an argument. So there's my input. Process is checks for double letters, da da da, replaces those double letters with just a single instance of that letter. Okay. This function should be case sensitive, so be sure to preserve the case for each letter, i.e. AA should be good. So it replaces it. Presumably it returns the replaced, it returns a string with the things replaced. So, now, so I think what I can do here is there's kind of a sneaky way to solve this one. I'm just trying to decide if I want to do it the sneaky way first or sort of the sneaky way is easier. I think I want to do the obvious way, which is a little harder here. I might have to look at my previous solution. What did I do? The sneaky way or the obvious way? I did... Oh, I did a one of those. Okay. So I'm... okay, yeah. So let's do the obvious way. Okay, so the obvious way is... The obvious way, what I'm calling the obvious way, is just sort of a vanilla accumulator, kind of straightforward procedural accumulator. So I'm going to call this text in for input, and I'm just going to call my accumulator text. You call it text out, I guess, but we'll just start an empty string, and we'll iterate through text in. And if character is not equal to the previous character, then we'll add it in. If it is equal, then we just won't add it in. So this is kind of a funny thing where you're trying to discern if at any point, you know, you're making a decision about at a given point in the string based on the neighboring point. So it's a little bit of a weird one. So because of this, so I have my, let's call this current character, and I could either do this with by comparing the current character, which is the character that the for loop is currently, you know, going through, current character with the next character or the previous character. I'm going to do the previous character. So I could say previous I'm going to say CRNT and prev. So current character and previous character equals text in sub whatever the index of the current character is minus 1. So now I need the index. Let's call it IDX. And in order to get the index, we'll enumerate. And we'll say IDX, current character. So for the index and the current character and the enumerated text input, we'll say previous character equals text in sub IDX minus 1. There is a way to do this with zip if you're wondering. Yeah. So now the problem is IDX starts at 0. 0 minus 1 is negative 1. Text in sub negative 1 is, think about this. What is text in sub negative 1? What is my input text sub negative 1? What is that? A list or a string or a tuple sub negative 1 gives you what? Think about that. So you may recall that negative 1 is a valid index. It gives you the last element in the collection. And I don't want to do that because that would mean the first thing I'd be comparing is H and question mark, right? Which would be fine in this case, but you know, like what if my last character was also a lowercase h? Well, then that would prevent me from adding this current h here. So I don't want to do that. So what I want to do is just skip this first iteration. I'll say if IDX equals 0, continue. So this continue just skips that iteration. And there was something else I had to do here. Yeah, okay. Let's see, I'm just modeling this. Okay. So if IDX equals this, we do want to accumulate the current character in here. So we'll say text plus equals current character. And then we also want to say if shoot, I got to set the previous one. Where do I set the previous one? Ah, I just need to look at my previous solution. Right, okay. So my previous character, I'll just set this above, right? And I'll say if current character and previous character are, what do I want to do, not equal. So if current character not equal previous character, then I can, then I will do this. Like I said, remember I made that big stink about you should always return as soon as you know what thing you want to return, and I forgot to do that again. Okay, let's return it. And I don't know, I'm not quite sure where this is getting me. This might be it. So let's see. Let me copy this. I should have an H there now, actually. Did that do it? That looks like it did it. Okay. See, sometimes this is why it's nice to have this reasoning done before you start on the solution, because sometimes you're like, this might have solved the problem, and you run it and it did, or not, but it's weirdly easy to accidentally solve a problem. So let's see what I had here. I know I had to kind of cheat and look at my prior solution. Now that I yeah, you'll see this other solution is a little less obvious, but it's easier to think about. So yeah, I'm doing exactly the same logic for this. Did some different variable naming, but same diff. Okay. So now let's look at the easy solution. The easier but slightly less obvious solution. Let me know if you see what I'm doing here. Hmm. Hmm. Cool. So here I just made an alphabet variable that contains all the lower and uppercase characters of the alphabet plus a space, and the space is just in the middle, just so this kind of flows a little better. A B C D E F G H I J H I J K L M N O P Q R S T U V W X Y Z. Okay, I did that to prove to you all that I know the alphabet. So now we're good. No, I just wanted to make sure that I got all the letters and didn't miss one or something. Okay, so we've got the complete alphabet. So we can do for letter in alphabet, and we'll just check every valid character that we want to deduplicate. And then I can say if let plus let plus let is a double letter. So if let, or I could do let times 2. This also expresses a double letter, right? Let's just look at that real quick. So I could use let or let times 2, let plus let. Right, so this is going to be a string of double letters. We're going to get a bit of output here, but that's okay. ZZ, YY, and I'm getting double letters because I did this in 2 different ways. So I'll use let times 2. So we'll say for letter in alphabet if double letter, it's kind of even more reads like double letter if it's like 2 times that. So if double letter in text dot in text sub in, then we'll say text, and I'll just do this. I'll just call this text. I'll say text equals text dot replace we'll do it in a variable. Double equals let equals 2 times let if double let in text, replace double let with let. Return text. So this is, I would say, easier and better logic, but less obvious. I would say it's a little bit of a less obvious solution because you're not iterating through the text, right? You're iterating through something else that you just made up. You're iterating through that, and you're using that. So it's a different way of, very different way of thinking about the problem, but I think this is a better solution. And this is the solution that was actually given. I don't have one in here. And then I have this ridiculous solution down here, which is somebody was like, I remember I went through this on stream a while ago, and I had somebody say like they wanted me to solve it with a comprehension. And this is, I believe this is a working comprehension solution, although it's obscene, and it's just, there's a lot going on here. So I'll put those in the chat if you want to go look through them, but I'm not going to go through that solution again. It is ridiculous. Cool. Chew on those as you will. Awesome. Oh, did I actually submit? I don't think I actually submitted that. There we go. Very good. Cool. Well, that was fun. That puts us right about at time. This is about the time that we normally wrap up for study halls, so I think we can call it here. If you're watching, go ahead and give us a like, comment, and subscribe if you're not. If you like to, don't want to force that, but yeah. And if you're not on the Galvanize Slack channel, we have links in the description where you can sign up and join the Basic Prep Slack channel, which is free, and you'll be free to participate in study halls as you like. Do feel free to DM me. Apologies in advance. I know I can be a little slow to get back to folks. I will try to get back to you as soon as I can, though. Yeah, feel free to DM me. Ask questions in Basic Prep outside of study hall hours. Ask me questions, whatever you want to do. So, yeah, we'll wrap it up here. It's been a pleasure. Hope this was helpful and fun for you all as well. Y'all have a good rest of your day. Bye-bye.